All right, let's go. Number 10. The 1091 London Tornado. Something happened to the Church of St. Mary Le Bow in Cheapside on the afternoon of October 23, 1091, that the chroniclers of the time did not have a word for. They described what they saw. Roofs lifting off timber structures as if pulled by an invisible hand. Walls peeling apart along their joints. Bodies in the air. 6 oak rafters, each 26 feet long, wrenched from the church roof and driven vertically into the earth, with such force that only 4 feet remained visible above the surface. The chroniclers recorded all of it. They recorded the sound. They recorded the direction. They recorded the path it cut through the most densely packed quarter of the largest city in England. What they could not record was what it was, because the word did not yet exist in English, and the phenomenon it described did not belong to this part of the world. 900 years later, meteorologists applied a modern damage classification framework to those same accounts. The rating they returned was T8 on the Toro intensity scale. That is the same classification assigned to the tornadoes that flattened prefabricated housing across the American Great Plains. Except this was not the Great Plains. This was a city built entirely of timber and thatch, packed into streets so narrow the funnel had nowhere to dissipate. And the atmospheric conditions that produced it are not historical. They are projected to increase. Cheapside in 1091 was not a wide boulevard. It was a corridor. The buildings on either side leaned toward one another from their upper stories, close enough in places that a person on the second floor could reach across and touch the building opposite. The streets were packed earth and mud, lined with market stalls selling bread, leather, ironwork. The air on an October afternoon smelled of damp thatch, wood smoke, and animal waste. The sound of the market was a continuous low noise, cartwheels on mud, voices negotiating prices, livestock in pens behind the shops. When the funnel entered the quarter, the market sounds stopped, not gradually, simultaneously. The wind displaced the air in the corridor, with a force that collapsed stalls before the debris arrived. The sound that replaced the market noise was later described as continuous thunder, a sustained roar moving in a single direction down the street, carrying timber, roof thatch, and anything not anchored to a foundation. The mechanics of what happened are now well understood. A cold continental air mass from the north collided with an unusually warm Channel Maritime air mass moving northeast. The thermal differential created a mesocyclone, a rotating updraft, that touched down in the heart of London and tracked through the densest urban construction in England. The streets of Cheapside did not dissipate the wind. They channeled it. The narrow lanes compressed the airflow the same way a nozzle increases the velocity of water through a hose. The wind speed at the center of the corridor was higher than it would have been in open terrain. The buildings were not shelter. They were infrastructure for acceleration. The evidence of that acceleration is in the rafters. 6 oak beams, each 26 feet long, torn from the roof of St. Mary Le Bow. English green oak at that length weighs several hundred pounds per timber. The force required to extract a seated rafter from its joint, lift it clear of the roof structure, and drive it vertically into compacted London clay to a depth of 22 feet is not trivial. It is measurable. The depth of penetration is a direct function of wind speed and rotational energy. The rafters are, in effect, a medieval wind gauge. They recorded the intensity of the tornado in the language of physics, driven into the ground like stakes in the earth of a city that did not know what a tornado was. No one in London on that October afternoon understood what had happened. The word tornado would not appear in English for centuries. The chroniclers used the only frameworks available to them. Some wrote of storms. Some wrote of divine anger. Some simply described the effects. Roofs gone, walls flattened, bodies found at distances that did not match where those people had been standing, and left the cause unnamed. The absence of a conceptual category meant the event could not be classified, recorded accurately, or prepared for. It was not denied. It was not debated. It simply could not be described. The same pattern repeats in the modern era whenever an event falls outside the framework available to the people experiencing it. The language fails first. The understanding follows. In 2004, a team led by atmospheric scientist Matthew Clark at the Toro Research Group reconstructed the 1091 event using the contemporary accounts and applied the standardized damage classification framework. The rating they returned was T8. But here is where the comfortable reading collapses. The atmospheric conditions that generated a T8 over London in 1091 are not a medieval anomaly. They are a product of the thermal differential between Channel sea surface temperatures and continental air masses. That differential is not shrinking. Sea surface temperatures in the English Channel have risen measurably over the last century. The frequency of the thermal collision patterns that feed mesocyclone development is expected to increase. The United Kingdom already records an average of roughly 30 tornadoes per year. Most are weak. Most occur in rural areas. The question is not whether the conditions that produced the 1091 event can recur. The conditions recur routinely. The question is, what happens when a T8 mesocyclone meets a modern city built in glass curtain wall construction on the same geography that funneled the medieval event through a corridor of timber? The wind does not know what century it is. Number 9. The 1287 St. Lucia's Flood. In 1995, a team of geologists, led by Sjoerd Jelgersma at the Geological Survey of the Netherlands, was mapping sediment cores along the former southern boundary of what had once been the Zuiderzee. At a depth of approximately 2 meters, the cores transitioned. Below the line was compacted peat and clay, the signature of dry agricultural land. Above the line was marine silt, shell fragments, and saltwater microfauna. The transition was not gradual. It was a knife edge, 1 centimeter of Dutch farmland. The next centimeter, sea floor. Something had turned solid ground into open ocean, and it had done so fast enough to leave no transitional sediment between the two states. That something was a single North Sea storm surge on the night of December 14, 1287. It broke through the coastal barriers of the northern Netherlands and did not recede. The Zuiderzee, an inland sea large enough to reshape the geography of an entire nation, did not exist on the morning of December 14th. By dawn on the 15th, it did. The inundation covered an area roughly the size of modern metropolitan Amsterdam. The storm surge overwhelmed the natural sand dune barriers and earthen dikes that had protected low-lying farmland and fishing villages behind the coast. The water did not arrive as a wave and retreat. It arrived and stayed. The land behind the barriers sat below sea level. Once the barriers were breached, the North Sea filled the depression the way water fills a bowl. Villages that had stood on dry ground at sunset were under meters of salt water by midnight. Roads, field boundaries, churches, livestock, all of it submerged in darkness, with no warning system, no elevated ground to flee to, and no understanding of what was happening until the water was already inside the walls. Between 50,000 and 80,000 people drowned in a single night. That is roughly the population of a modern, mid-sized European city. Not over weeks, not over the course of a siege or a famine. In the hours between sunset and sunrise. The North Sea coastline of the Netherlands was redrawn in those hours. Islands vanished. Peninsulas became archipelagos. Entire fishing communities that had operated in sheltered estuaries found themselves facing open ocean. The fresh water sources were salinated. The agricultural land that survived was poisoned by salt. The economic infrastructure of the northern Netherlands was not damaged. It was replaced by a body of water that had not existed 12 hours earlier. Trade routes that had crossed dry land now crossed open sea. Markets that had been supplied by overland cart now required boats. Fishing communities rebuilt on new coastlines that were themselves unstable, subject to the same storm surges that had created them. The salination of agricultural soil was not temporary. Salt and clay soil at that concentration does not flush in a season. It persists for decades. The farms that survived the flood were not the same farms afterward. Their soil had been chemically altered by a single night of saltwater immersion. In 2009, researchers at Utrecht University published a sedimentological analysis of the 1287 surge deposits and estimated the peak water level at approximately 2 meters above the modern standard high water mark across the breach zone. But here is where the standard explanation falls apart. The Netherlands has since built the most advanced flood defense system on Earth. The Delta Works, the Maaslandkering, the Afsluitdijk, 32-kilometer dike spanning the former Zuiderzee mouth. The engineering is extraordinary. It is also the single point of dependency for a nation that now sits further below sea level than it did in 1287. The land has been reclaimed, drained, and settled. Nuclear power plants operate on reclaimed polders. Data centers serving the digital infrastructure of Western Europe sit below the waterline. The Port of Rotterdam, the largest port in Europe, processes over 450 million tons of cargo per year on land that was seafloor 7 centuries ago. The flood defense system does not eliminate the vulnerability. It concentrates it. A coordinated failure during a surge of 1287 magnitude would inundate land that now holds more people, more critical infrastructure, and more irreplaceable systems than the fishing villages that drowned on that December night. The Netherlands did not defeat the sea. It borrowed the land back under terms the sea did not agree to. Every day the pumps run is a day the arrangement holds. The sea has not forgotten where it was. Number 8. The 869 Jogan earthquake and tsunami, 3.7 centimeters. That is the thickness of a sand deposit found 2.4 kilometers inland from the modern coastline of the Sendai Plain in northeastern Japan. 3.7 centimeters of medium-grain marine sand laid down in a single depositional event, buried under 12 centuries of soil accumulation. Sand does not travel 2.5 kilometers inland from the sea under normal conditions. River floods carry fine silt and organic material. Storm surges leave salt and scattered shell fragments close to the coast. A marine sand layer of that grain size, at that distance, deposited in a single event across a lateral extent of dozens of kilometers, means one thing: a tsunami. And the radiocarbon dating of the organic material directly above and below the sand places the event precisely. 869 CE, the year the Pacific Ocean entered the Sendai Plain and stopped where the foothills began. The Japan Trench runs parallel to the northeast coast. It is a subduction zone, where the Pacific Plate slides beneath the Okhotsk Plate at a rate of roughly 8 centimeters per year. When the accumulated strain exceeds the frictional lock between the two plates, the overriding plate snaps upward. The seafloor displacement generates a wave. The magnitude of the 869 rupture, reconstructed from the sand deposits and calibrated against the coastal geology, is estimated at 9.0. The energy released was equivalent to the detonation of roughly 480 million tons of TNT. That is approximately 32,000 times the energy of the bomb dropped on Hiroshima. The wave generated by that displacement crossed the shallow coastal shelf and made landfall across the Sendai Plain, penetrating kilometers inland and depositing the sand layer that would sit undiscovered for over 1,000 years. The Nihon Sandai Jitsuroku, the official court chronicle of Japan, contains entries from 869 describing what happened. The account was written in Kyoto, hundreds of kilometers from the coast, based on reports that traveled overland. The text describes violent shaking, a great wave, coastal settlements destroyed, fields flooded with seawater. The language is restrained. The chronicler recorded what was reported, not what was felt. The distance between the court and the coast flattened the event into administrative prose. Hundreds dead, settlements lost, farmland ruined. The numbers were imprecise, because no one on the coast survived in sufficient numbers to count accurately. The sand sat undisturbed for over 1,000 years. In 2001, a research team led by Koji Minora at Tohoku University published a paper identifying the Jogan tsunami deposits across the Sendai Plain. The paper did not merely describe a historical event. It made a prediction. The researchers mapped the inland penetration of the 869 wave, identified the fault segment responsible, and stated that the same segment would rupture again with comparable magnitude. The paper named the coastline. It named the expected magnitude. It identified the inundation zone. The Fukushima Daiichi nuclear power plant sat inside the mapped zone. But here is where the nightmare begins. The paper existed. It was published in a peer-reviewed journal. It was available to every regulatory body and engineering firm operating on the Sendai coast. The prediction was not vague. It named the fault. It named the magnitude. It described the expected tsunami height and inland penetration. 10 years later, on March 11, 2011, the Tohoku earthquake ruptured the same fault segment at magnitude 9.1. The tsunami penetrated the Sendai Plain along almost exactly the path the sand deposits had already recorded. Fukushima Daiichi, built on the coast the paper had identified, suffered 3 reactor meltdowns. The sand had told the future in 869. The geologist had translated it in 2001. The warning was specific, published, and available. The plant was not moved. The defenses were not raised. The medieval event replayed itself on the same coastline, at the same magnitude, along the same inundation path, and the sand layer that recorded the first event now sits beneath a second one. The question is not whether the geological record can predict the future. It can. The question is whether anyone will read the next warning differently than they read the last one. Number 7. The 1202 Near East Earthquake. The morning of May 20th, 1202 began like any other in the Crusader port city of Acre. Merchants setting up stalls in the covered market. Donkeys loaded with grain moving through the narrow stone streets. The massive defensive walls that had resisted Muslim siege for decades, casting their usual shadow across the harbor quarter. The stones of those walls had been fitted by the finest military engineers in Christendom. They were built to absorb the impact of catapult projectiles and battering rams. They were not built for what happened next. At approximately dawn, the Dead Sea Transform Fault ruptured along a segment stretching from the Gulf of Aqaba to northern Syria. The shaking lasted long enough to bring down structures that had stood for a century. The walls that had held against armies did not hold against the ground itself. The death toll recorded by contemporary Arabic historians defies easy comprehension. Some sources place the number above 1 million. Even conservative modern revisions estimate the dead in the tens of thousands across the affected zone. To place the number in a physical frame, the upper estimate exceeds the entire population of any single European city at the time. The destruction was not concentrated in one location. Nablus was leveled. Acre was heavily damaged. Tyre lost major structures. Tripoli suffered catastrophic collapses. The earthquake did not strike a city, it struck a region, simultaneously, across hundreds of kilometers of fault line. The stone construction that made Crusader fortresses formidable against human siege became the instrument of death. Vaulted ceilings collapsed as single units. Walls toppled inward. The narrow streets became canyons of rubble, with no space to flee and no light to see by once the dust filled the air. The earthquake arrived during the Crusades, and its military consequences were immediate. Fortresses that had defined the strategic balance between Crusader and Muslim forces for decades were reduced to rubble in seconds. The engineering that had made them impregnable against human armies was irrelevant against seismic force. Walls designed to absorb horizontal impact from projectiles had no capacity to absorb the vertical and lateral acceleration of an earthquake. The political map of the Crusader states was redrawn not by siege, not by negotiation, not by any decision made by any commander, but by the movement of a fault line that did not distinguish between Christian stone and Muslim stone. And yet, almost no one outside specialist seismology has heard of this earthquake. One of the 5 deadliest seismic events in all of recorded human history occurred during one of the most studied periods of medieval history, and it occupies almost no space in the Western historical narrative. The Crusades are remembered through battles, treaties, and kings. The earthquake that reshaped the military landscape more thoroughly than any army is a footnote. The erasure is not accidental. It reflects a historiographic framework that privileges human agency over geological force. The chronicles survived. The accounts are detailed. The event is simply absent from the version of the Crusades that most people learn. In 2004, a paleoseismic study led by Shmuel Marco at Tel Aviv University mapped the 1202 rupture zone using trench excavations and offset measurements along the Dead Sea Transform. The study confirmed a lateral displacement consistent with a magnitude of 7.5 or higher across a rupture length exceeding 200 kilometers. But here is where the comfortable reading collapses. The Dead Sea Transform Fault has not produced a comparable rupture in over 800 years. In seismology, a long recurrence interval on an active fault does not mean the hazard has decreased. It means strain is accumulating along the locked segment. The longer the interval, the larger the stored energy. The fault runs directly beneath the modern cities of Amman, Beirut, Damascus, and the densely populated coastal corridor of Israel. 8 centuries of construction now sits on a fault that has been building pressure since the last time it moved. The silence is not safety, it is storage. The fault does not know it has been forgotten. It does not know that 8 centuries of cities have been built on top of it. It only knows that it has not moved yet. Number 6. the 1356 Basel Earthquake. In 1999, a team of Swiss geologists, led by Donat Fay at the Swiss Seismological Service, cut a trench across the Rhine-Graben fault zone just south of Basel. The trench walls revealed a clean vertical displacement in the sediment layers, a fault scarp buried under centuries of alluvial fill. The offset was measurable. The dating was precise. The displacement matched the historical record of a single event, October 18, 1356, the day the city of Basel was destroyed. But what caught the team's attention was not the medieval displacement. It was the material sitting directly on top of the fault trace in the modern era. Poured concrete foundations, industrial pilings, chemical storage infrastructure. The fault that had leveled a medieval city now ran directly beneath the foundations of one of the most concentrated pharmaceutical and chemical manufacturing corridors in Europe. Basel, on the morning of October 18, 1356, was a prosperous trading city on the Rhine. Stone buildings lined the riverfront. Churches anchored the major intersections. The city walls were thick and well-maintained. By the end of the day, nearly every stone structure in the city had collapsed. The sound of masonry failing is not a single crack. It is a sustained grinding, stone separating from stone along mortar joints, followed by the percussive impact of the mass hitting the ground. In a city built of stone, the sound was continuous. Hearths that had been lit for the morning meal ignited the timber interiors of the collapsed structures. The fires spread. They burned for 8 consecutive days because there was no organized response. The civic infrastructure that would have coordinated firefighting, water distribution, and rubble clearance was itself rubble. Castles collapsed across a 30-kilometer radius. The destruction was not urban, it was regional. The Rhine ran through the center of the destruction. In 1356, the river was the primary artery of European north-south trade. Barges carrying grain, wine, iron, and timber moved continuously between the Alpine interior and the North Sea ports. The earthquake damaged bridges, collapsed wharves, and blocked loading points. The disruption to river commerce was immediate and lasted months. Markets that depended on Rhine shipments went unsupplied. The economic damage radiated downstream in a pattern that followed the river, affecting cities that had felt no shaking at all, but whose trade depended entirely on the corridor that had just been severed. In 2004, the Swiss Seismological Service published an updated hazard assessment of the Rhine-Graben zone. The study concluded that the recurrence interval for a 1356 magnitude event was between 2,000 and 5,000 years, placing the current moment within the statistically active window. But here is where the nightmare begins. Medieval Basel burned. The fires consumed timber interiors, destroyed records, and killed an unknown number of people trapped in rubble. But the city was rebuilt within a generation. The damage, however catastrophic, was structural. It was stone and wood and flesh. Modern Basel is different. The Rhine corridor between Basel, Mulhouse, and Freiburg hosts the global or European headquarters of several of the largest pharmaceutical and chemical manufacturing companies on Earth. Their facilities include storage infrastructure for chemical precursors, intermediates, and finished compounds. Some of these substances become dangerous at concentrations measured in parts per billion when introduced into a water system. The Rhine watershed downstream of Basel supplies drinking water to approximately 20 million people across Switzerland, France, Germany, and the Netherlands. A seismic event of 1356 magnitude does not merely collapse buildings, it breaches containment, and the contents do not stay in Basel. They follow the river. The same river that carried medieval trade now carries the potential for chemical distribution across 4 countries within hours of a rupture. The medieval city could burn for 8 days and be rebuilt. A modern Basel earthquake would not burn. It would leak, and the leak would follow the current, moving north at the speed of the Rhine, passing through water treatment intake after water treatment intake, each one drawing from the same contaminated flow. The fault does not distinguish between a medieval trading city and a modern chemical corridor. It only knows how to move. Number 5. The 1342 Magdalene Flood. More erosion in a few days than in the preceding 2,000 years. That is not a metaphor. That is a measurement. In 2006, a team led by geomorphologist Hans Rudolf Bork at Christian Albrechts University in Kiel published a quantitative erosion analysis of Central European river valleys. The finding was specific. The flood event of July 1342 removed more topsoil from the landscapes of Central Europe than all rainfall, all river activity, and all agricultural disturbance in the 2 millennia before it combined. The number is difficult to hold in the mind. 2,000 years of geological accumulation, gone in days, and the land has not recovered. Nearly 700 years later, the soil is still missing. The weather pattern that produced it is now classified as a VB cyclone. A low-pressure system originating over the Mediterranean tracked northeast, crossing the Alps and pulling massive volumes of warm, moisture-laden air into Central Europe. The system stalled. It did not pass through. It sat over the river basins of the Rhine, the Danube, the Main, the Elbe, and the Moselle, and it rained. Not for hours, for days. The ground was already saturated from earlier storms. There was no absorption capacity left. Every river system in the region began to rise simultaneously. Not one river, not a regional cluster. Every major drainage basin in Central Europe exceeded its banks at the same time. The volume of water moving through those systems simultaneously has no clean modern comparison. The discharge rate across all affected rivers combined exceeded anything recorded in the instrumental era by a wide margin. Topsoil is not deposited, it is built. The process begins with bare rock. Weathering breaks the surface into mineral fragments. Lichens colonize. Their acids dissolve more rock, organic material accumulates, microbial communities establish themselves, root networks bind the particles, earthworms aerate and mix the layers. The formation rate of arable topsoil in a temperate European river valley is measured in fractions of a centimeter per century. 1 centimeter of productive soil represents generations of biological and geological labor. The river valleys of Central Europe had been accumulating this soil for thousands of years. The depth in some areas represented the entire post-glacial period. The flood stripped it to the substrate, clay. Mineral subsoil, rock. The dark, fertile layer that had defined the agricultural capacity of the region for millennia was carried downstream in suspension, deposited in floodplains and deltas as sediment, and lost to the valleys that had produced it. The waterline marks are still visible. In Prague, in Würzburg, in dozens of Central European cities, medieval stone structures carry the high water marks of the 1342 event. The marks sit above the levels of every subsequent flood in the recorded history of those cities. The color of the floodwater was not the gray-brown of normal river flooding. It was black with topsoil. The water carried the land itself. When the rivers finally receded, the fields did not look like fields. They looked like a different landscape. The dark surface was gone. What remained was pale, mineral, and sterile. The smell of exposed subsoil is distinctive. It is the absence of the organic richness that characterizes living earth. It smells like clay and wet rock. It smells like nothing is growing. The loss was not temporary. Soil science confirms that formation rates in temperate Europe operate on timescales measured in centuries per centimeter. The soil removed in July of 1342 had taken roughly 5,000 years to accumulate. At natural formation rates, it would take a comparable span to replace it. Some of the affected valleys have seen partial recovery through deliberate agricultural management. Some have not recovered at all. The land is measurably less productive today than it was before the flood. 700 years is not long enough. But here is where the standard explanation falls apart. A flood is understood as a temporary event. Water rises, water falls. Damage is repaired. The landscape returns to its previous state. This is the framework that governs modern flood response, insurance models, and infrastructure recovery planning. The 1342 event broke that framework. The water was temporary, the damage was geological. A few days of rainfall reversed a process that operates on a timescale the human mind cannot intuitively grasp. Destruction and creation do not operate on the same clock. A weather event lasting days undid a geological process lasting millennia. The soil is still missing. It will be missing long after every structure standing today has been replaced. Number 4. The 1248 Mont Granier landslide. The valley beneath Mont Granier in the French Alps was farmland. Flat, fertile. crossed by tracks connecting the small settlements that dotted the floor of the Savoyard lowlands. The mountain rose above it to the east, a massive limestone face, one of the largest rock walls in the entire Alpine range. It had always been there. It had always looked the same. The villages at its base had been inhabited for generations. On the night of November 24, 1248, the face of the mountain moved. 500 million cubic meters of rock detached from the summit and descended onto the valley floor. The settlements below did not evacuate because there was no interval between the mountain being intact and the mountain being in the valley. The transition took seconds. 500 million cubic meters is not a number the mind can hold. Translated into a physical comparison, it is roughly the volume of 200 Great Pyramids of Giza, or the volume of water in 200,000 Olympic swimming pools, except it was not water. It was limestone. Moving at speeds estimated between 100 and 200 kilometers per hour down a slope steep enough to sustain acceleration across the full vertical drop. The debris did not tumble to a stop at the base of the cliff. It ran out across the valley floor for several kilometers, burying everything in its path under a layer of shattered rock, meters to tens of meters deep. Between 2,000 and 5,000 people died. The range is wide because no precise population record of the buried villages survives. The deaths were not distributed over hours or days. They occurred in the time it takes a rock mass traveling at highway speed to cross a valley floor measured in hundreds of meters. There was no flight because there was no time to understand what was happening before it was over. No eyewitness account from inside the event exists. No survivor from the directly impacted zone left testimony. The villages are known from records predating the landslide. After November of 1248, they do not appear in any record again. The silence is total. Not a single voice from inside the debris field. The transition from inhabited valley to burial ground lasted seconds, and the only witnesses were people far enough away to survive, which meant far enough away to see, but not to help. The air displacement ahead of the debris front was itself destructive. A rock avalanche of that volume pushes air in front of it like a piston. The blast of compressed air ahead of the rock was strong enough to flatten structures and strip trees before the debris arrived. The sound was audible for tens of kilometers, a sustained roar described in analogous modern rock avalanche events as louder than sustained thunder and lasting for the full duration of the collapse. The dust cloud that followed rose hundreds of meters and was visible for days. When it settled, the valley floor had been replaced by a hummocked field of shattered limestone. No trace of the villages was visible on the surface. In 2001, a geological survey led by Laurent Estrade at Université Savoie Mont Blanc mapped the debris field and reconstructed the failure mechanics. The study identified the cause as a failure along the boundary between karst limestone and an underlying clay marl layer, weakened by sustained water infiltration. But here is where the nightmare begins. Karst limestone overlying clay or marl is not a geological rarity in the Alps. It is a common stratigraphic configuration across dozens of valleys in the French, Swiss, and Italian Alpine ranges. The failure mechanism that destroyed the villages beneath Mont Granier, water infiltrating the limestone and lubricating the clay boundary until the friction drops below the gravitational load, is a standard geological process. It is happening now, slowly, in multiple locations. Monitoring systems exist for some of these sites, others are unmonitored. And the critical transition, the moment a rock mass shifts from slow creep to catastrophic release, can occur in hours or even minutes. The definition of adequate warning for a rock avalanche moving at 150 kilometers per hour across a valley floor 200 meters wide is not the same as the definition of adequate warning for evacuation. The debris field at the base of Mont Granier is not a historical monument. It is a demonstration, visible from satellite imagery, a geological proof of concept that the mountain range performs when the conditions are met. The mountain is still there. The clay is still beneath the limestone. The rain still falls. Number 3. The 946 Millennium Eruption of Paektu. In 1994, a glaciochemist named Clausen at the Niels Bohr Institute in Copenhagen was analyzing sulfate concentration profiles in the GSP2 Greenland ice core when a spike appeared in the 10th century layer. It was not a subtle elevation. It was a sharp, unmistakable peak in volcanic sulfate deposition, one of the largest in the entire Holocene record. The spike dated to approximately 946 CE. The chemical signature indicated a massive sulfur-rich eruption somewhere in the northern hemisphere. The magnitude implied by the sulfate loading was extraordinary. Clausen traced the geochemical fingerprint through tephra composition analysis and matched it to a source. The source was a volcano on the border between what is now North Korea and China. A caldera lake called Heaven Lake sits in its summit. The volcano is Paektu, and the eruption it had produced was one of the largest in the last 5,000 years of Earth's history. The atmospheric footprint was hemispheric. Ash from the eruption reached northern Japan, over 1,000 kilometers from the source. The tephra layer is identifiable in Japanese lake sediments and peat bogs across Hokkaido. The sulfate signature appears not only in the Greenland ice cores but in Antarctic cores as well, indicating that aerosol injection into the stratosphere was high enough and voluminous enough to cross hemispheres. Tree ring records from Siberia, Scandinavia, and Northern Europe show growth suppression in the years following 946, consistent with volcanic dimming of sunlight. The eruption was not a local event. It signed the atmosphere of the entire planet. The Kingdom of Balhae controlled territory across what is now northeastern China and the northern Korean peninsula. It had existed for over 2 centuries. It had diplomatic relations with Tang Dynasty China and with Japan. It administered cities, maintained trade routes, and produced a written administrative record. The Millennium eruption obliterated its heartland. The area surrounding the volcano, the core territory of the kingdom, was buried under pyroclastic deposits meters deep. The state did not fall to invasion. It did not decline over generations. It stopped. The administrative records cease. The diplomatic correspondence ends. The trade networks go silent. A kingdom of over 2 centuries simply vanishes from the historical record in the years following the eruption. What replaced it was not a successor state. It was a void. The Jurchen peoples who eventually settled the region built something new. The continuity was broken. The caldera sits directly on the border between North Korea and China. The summit, with its crater lake, is divided between the 2 nations. North Korea considers the mountains sacred. China considers the northern slope part of its territory. Neither nation permits unrestricted foreign scientific access. In 2016, a team led by James Hammond at Birkbeck, University of London, published a study using remote seismic data and limited measurements from the Chinese side to confirm that the magma chamber beneath Paektu is still being fed by a mantle plume. The chamber is not cooling. It is being actively resupplied with molten rock from the deep mantle. But here is where the standard explanation falls apart, and then falls apart again. The first impossibility is the eruption itself. One of the largest in 5,000 years, powerful enough to obliterate a kingdom and leave a chemical fingerprint on both polar ice caps, that is absorbed. The second impossibility is what sits on top of the caldera now, the most militarized border on Earth. A nuclear-armed state that does not cooperate with international scientific monitoring. The most critical data required to assess eruption risk, direct caldera floor deformation measurements, gas emission rates, real-time seismic arrays on the summit is either not being collected or not being shared. The assessment of eruption risk for a volcano with a confirmed active mantle plume and a Holocene track record of hemispheric scale eruptions is being conducted partially blind. The magma does not require a visa. The border is a human invention. The plume is not. Number 2. The 1110 Dark Moon Event, 18.3 nanometers. That is the dominant scattering wavelength of sulfuric acid aerosol droplets in the stratosphere when their mean diameter falls between 0.1 and 1 micrometer. At that particle size, the droplets scatter broad-spectrum reflected sunlight, which is what moonlight is, while allowing the shorter path-length point source light of stars to transmit with relatively minor attenuation. The physics is well understood. The particle size constrains the eruption type. The eruption type constrains the sulfur output, and the ice core sulfate deposits constrain the timing. Everything is known, everything except the source. In the spring of 1110, the moon disappeared. The event was recorded in the Peterborough manuscript of the Anglo-Saxon Chronicle, one of the most reliable documentary sources in medieval English history. The entry is precise. On the 5th night of May, The moon appeared bright in the evening, and afterward its light diminished little by little. As soon as night came, it was so completely extinguished that neither light nor orb, nor anything at all of it was seen. The chronicler noted the critical diagnostic detail. The stars were visible. The sky was not overcast. The moon's light was selectively removed while stellar light persisted. A medieval monk, writing 900 years before atmospheric spectroscopy existed, recorded exactly the observation a modern atmospheric physicist would need to diagnose the event. Volcanic aerosols in the stratosphere. Sulfur dioxide ejected above the tropopause converts to sulfuric acid droplets. The droplets are small enough to remain suspended for months to years. Their scattering properties are size-dependent. Moonlight, which is reflected sunlight and therefore broad spectrum, is scattered in all directions by particles in the 0.1 to 1 micrometer range. The light does not reach the surface. It is redistributed across the sky. Starlight, which arrives as point sources from near infinite distance, passes through the same aerosol layer with less total scattering because the optical path per source is narrower and the total brightness is already low enough that diffusion is less perceptible. The result is exactly what the chronicler described: a clear sky, stars visible, no moon. The observation is not poetic, it is diagnostic. The eruption responsible has never been identified. Sulfate deposits in Arctic and Antarctic ice cores confirm a major volcanic event in the 1108 to 1110 timeframe. Dendrochronological records from multiple northern hemisphere sites show growth anomalies in the years following. The climatic impact was real and measurable, but no caldera, no tephra layer, no geological feature on the surface of the Earth has been conclusively matched to the event. Candidates have been proposed. Hekla in Iceland erupted around this period, but its sulfur output does not match the magnitude implied by the ice core signal. Other candidates in the Pacific and in Southeast Asia have been investigated and not confirmed. The volcanic event that filled the stratosphere with enough aerosol to block moonlight across the northern hemisphere for months occurred within recorded human history, within documented observation, and the mountain that produced it remains unknown. The theological weight of a vanishing moon in 1110 cannot be overstated. The moon was not understood as a reflective body orbiting the Earth. It was understood as a light placed in the sky by God. Its disappearance was not a meteorological curiosity. It was a sign. The difference between an eclipse, which lasts hours and follows a predictable pattern that some medieval scholars could calculate, and a disappearance that lasted months with no explanation and no precedent, was the difference between a natural rhythm and a withdrawal of divine presence. The fear was not rational. It was existential. Something permanent had stopped being permanent. In 2014, a study led by Sébastien Gillet at the University of Geneva analyzed the 1110 event using ice core, tree ring, and documentary evidence. The study confirmed the atmospheric loading and the climatic impact but could not identify the source eruption. But here is where the standard explanation falls apart. The eruption has not been identified. That sentence sounds like a gap in the research. It is not. It is a statement about the limits of the geological record. Over 900 years of investigation, ice core chemistry, global tephra databases, satellite-era caldera mapping, and no confirmed match. A volcanic eruption large enough to fill the stratosphere, block moonlight, and alter tree growth across the hemisphere occurred within recorded history, and the volcano that produced it has not been found. The inventory of dangerous volcanoes is not complete. There are mountains on this planet with the capacity to reshape the atmosphere, and some of them are not in any database. The moon came back. It always has. The volcano is still out there. No one knows which one it is. Number 1. The 1346 Siege of Caffa and the Black Death. The Mongol army of Johnny Beg had been encamped outside the walls of Caffa, a Genoese trading colony on the coast of Crimea, for months. The siege was not going well. The walls were holding. The Genoese supply lines by sea remained open. The Mongol cavalry, devastating in open terrain, had no mechanism for breaching stone fortifications defended by crossbowmen. It was a standard medieval siege, slow, expensive, and grinding toward stalemate. Then something inside the Mongol camp changed. Soldiers began dying, not from wounds, not from skirmishes. They were dying of something their field physicians could not identify, and could not stop. The dying accelerated. Within weeks, the camp was losing more men to the sickness than it had lost to the entire siege. What happened next was not a retreat. It was a decision. Yersinia pestis enters the body through the bite of an infected flea. The bacterium migrates to the nearest lymph node and begins replicating. The node swells. It becomes the bubo that gives bubonic plague its name. From the lymphatic system, the bacterium can enter the bloodstream, producing the septicemic form. Mortality in untreated septicemic plague approaches 100%. If the bacteria reach the lungs, the disease becomes pneumonic. The pneumonic form is airborne. It transmits between humans through respiratory droplets. No flea is needed. No rat is needed. A single cough in a crowded room. The progression from initial flea bite to pneumonic transmission is the progression from a controllable animal-borne disease to an uncontrollable airborne epidemic. The jump between those two states can occur inside a single human body. Janny Beg ordered the corpses of his own plague dead loaded into catapults and hurled over the walls of Caffa. The account comes from the Genoese notary Gabriele de Musi, who described the event in his chronicle Historia de Morbo. Whether the catapulted corpses were the primary vector of transmission into the city, or whether the plague had already entered Caffa through rat and flea populations moving between the siege lines, remains debated. What is not debated is what happened next. The Genoese fled. They boarded their ships and sailed west. They made port in Messina, Sicily, in October of 1347. The rats in the holds carried the fleas. The sailors carried the pneumonic form. Within 3 years, between 30 and 60% of the entire population of Europe was dead. Estimates range from 75 to 200 million. The death toll resists comprehension. To translate it into physical terms, the upper estimate of 200 million is roughly equivalent to the current combined populations of France, Spain, and Italy, erased, in 3 years. The feudal labor system that had governed European economic life for centuries collapsed not because of ideology or revolution, but because there were not enough living peasants to work the fields. Surviving laborers could demand wages. Landlords who refused found their fields unplanted. Serfs who had been bound to land for generations walked away because there was no one left to stop them. The economic architecture of medieval Europe was rewritten not by a theory, but by a labor shortage so severe that the power relationship between lord and peasant inverted within a single generation. Yersinia pestis is not extinct. It was not eradicated. It was not driven into the fossil record by modern medicine. It circulates today in rodent populations on 6 continents. Prairie dog colonies in the American Southwest test positive for plague routinely. Ground squirrels in Central Asia carry it. The World Health Organization records between 1,000 and 3,000 cases of human plague per year globally. The organism that emptied Constantinople in the 6th century, that killed a third of Europe in the 14th, that returned in wave after wave for 500 years, is alive. It is in the soil. It does not know that 7 centuries have passed. It does not know that antibiotics exist. It knows how to enter a lymph node, how to reach the lungs, and how to ride a cough from one body to the next. In 2013, a team at McMaster University, led by Hendrik Poinar, extracted Yersinia pestis DNA from the dental pulp of 14th century plague victims buried in the East Smithfield Cemetery in London. The genomic analysis confirmed that the medieval strain is the direct ancestor of plague strains circulating in modern rodent populations. The organism has not changed. The lineage is unbroken. But here is where the standard explanation falls apart. Yersinia pestis is treatable with antibiotics: streptomycin, gentamicin, doxycycline. The treatment is effective if administered early. That is the reassurance. The reassurance assumes the pharmaceutical infrastructure that manufactures, distributes, and administers those antibiotics will be fully operational at the moment the bacterium next emerges from its rodent reservoir into a human population center. That infrastructure has existed for less than 80 years. The bacterium has existed for at least 20,000. The margin between medieval behavior and modern containment is not a biological barrier. It is a logistical one, a supply chain, a cold chain, a network of hospitals, pharmacies, and diagnostic labs that must all be functioning simultaneously in the right place at the right time. The organism does not need to evolve. It does not need to mutate past the antibiotic. It only needs to arrive somewhere the logistics have failed. Every other disaster in this countdown was inflicted by the planet. Geology, weather, atmosphere, forces that do not negotiate and cannot be blamed. This one was different. This one was a decision. A commander losing a siege loaded the dead into catapults and threw them over the wall. The Genoese fled by ship. The ships made port. A continent died. The chain of causation from one tactical decision during a failed siege to the death of 75 to 200 million people spans a few weeks and a few hundred nautical miles. The organism that made it possible is still circulating, still viable, still waiting in the soil for the conditions that have occurred before and will occur again. The ships have always been sailing. The harbors have always been open. If you want to see more videos like this, click the video on screen now and make sure to subscribe.